regarding 3D shotcrete printing. This morning we talked a lot about decarbonizing the construction industry. We talked, for example, about the current stage of CCS, CCU technology in cement production. And now we will see another approach of how to decarbonize our industry. And I would like to welcome Nora Baum. I'm hearing her talking about Sonocrete.
Yes, thank you very much. Hello, everybody. I'm Nora. I'm from Sonocrete. And we are trying to make concrete, especially precast concrete, climate friendly. When you make concrete, cement is the key ingredient, right? It's the reactive component next to water that you need. But cement has a couple of problems. Number one, Alexander just mentioned it, it's creating 8% of the global carbon emissions. So many people are not even aware that if you build a house from concrete, that this is a massive polluter to the climate. So this is the one problem. There is another problem, and that is cement is getting more and more expensive, especially in Europe, where the emission trading system, I see some people nodding heads, yeah. So this emission trading system that we always thought of as being a paper tiger, but it has somehow become a real thing. So last year, the prices for emitting carbon they have gone, like when we always say in our office, when they went over 62 euro, our phone started ringing and never stopped since. Because all of a sudden, reducing carbon has become an economically good thing to do. So we've seen a 25% price increase for cement happening up to today, and there will be another probably 30–40% price rise. The problem is, cement is a hard thing to replace. You cannot make precast concrete with simply putting in less cement, because what would happen is you would need to wait longer until you can strip the elements. So to take out the elements, this is the rhythm of the production. And if there is less cement in, this rhythm will slow down. So that would mean in the end that a precast company could only produce, like, I don't know, let's say half the elements that they were planning for, which would mean it would have to reduce half the jobs, etc. Right? So this is a massive problem, and would also not help us in building more in Berlin, where everybody wants to live, seemingly. So this is why you cannot simply reduce the cement just like that. And this is exactly where Sonocrete is coming in. What we've created is a device that uses high-power ultrasound. It's a pre-mixing device, and with the help of the high-power ultrasound, the cement hydration, so the reaction that makes the concrete get hard, is accelerated. And with this acceleration, we reach early compressive strength faster. What does that mean? It means if you take a concrete recipe and you apply ultrasound to it, you can strip this element earlier, or you can use less cement to produce it. And this is what all our partners are asking for. So what you can achieve is a 30% reduction in the carbon emissions that were generated from the cement you save when using ultrasound. You could also reduce heat treatment. It's something that nobody really ever thought about, but we are heating concrete elements with gas in Germany, and we're speaking about not heating our flats anymore, right? So this seems a bit absurd these days. And you could also reduce this heat treatment, or you could strip earlier. It's something when we started, like 4 years back, we thought this would be our key selling thing. Turns out it's not. People want to reduce the carbon from their production, which is a good thing, I think, for all of us. So how does it work? It's a bypass system. So we take approximately 20% of the cement and a bit of the water, and we treat this with a high-power ultrasound before the concrete mixing process starts. When it's time for mixing, basically this suspension, we call it, this activated suspension is added to the mixer along with all the other ingredients, so the rest of the water, the rest of the cement, and the aggregates. And what the ultrasound does is basically two things. The one is the dispersion effect. So the cement is like finer, right? If you make cacao and milk and you just stir it with a spoon, there are like clumpy stuff in it. And if you use ultrasound, this will just disperse. The one thing. The other thing is that in order to make concrete hard, there are CSH phases growing in it. So it's basically like little fingers that are growing and they're interlocking. And with the ultrasound, we induce cavitation. That's basically imploding bubbles. And when these bubbles implode, they create high pressure and high temperature. And this is an optimal seeding place for the CSH phases. So showing you this from the scanning electron microscope, you see on the top, it's an unsonicated sample of concrete, basically. And the CSH phases, you can not really see them in the first picture. There are only a few of the very small white blocks. They are growing after 4 hours, and there are a lot of them after 6 hours. But if you look at the sonicated sample, after 2 hours, you can already see, well, I hope you can see it, there are a lot of those little white blocks, and they are very evenly distributed. So everywhere are CSH phases starting to grow. And with them being everywhere, it means when they start to grow, they can interlock very quickly. And that's what you see after the 4 hours, and then after the 6 hours, it's practically done. And so this is what happens like on the chemical side. I brought you an example here. It's something we've been doing with a partner just this summer. So looking at the right side first, you see where we started. Reference that says this is the standard concrete recipe. It was using 380 kilograms of SEM1. SEM1 essentially means, some of you might more know OPC, ordinary Portland cement, but it's cement with, most of it is clinker, so that means it's producing a lot of carbon in order to make this. So what we did, we reduced this from 380 to 320 kilogram per cubic meter, and we replaced the SEM1 with the SEM2. And the SEM2 is basically cement that only has about like 60 to 70% of this clinker, so the CO2 creating material, and the rest is other stuff. So that means it's basically a double reduction, and in the end, that makes a 30% carbon reduction. And now we're looking at the left side. And what we see is that both of these samples were ready. They had the same early compressive strength, which is what you need to strip a mold after 8 hours. And the 8 hours was the relevant time for this partner. So this was the time when they wanted to open their molds, take out the thing, and it was ready after 8 hours. So 30% less carbon, but the same time for stripping. So that's a big success, and it's one of our partners now, so we will be delivering a plant. Speaking about Sonocrete, we're also a startup. I felt very much like comparable. We are like 4 years old, we're 18 people, and from, I could say Berlin, but actually it's Cottbus, so close to Berlin. So basically we have this technology patented, and we've been in the lab for years and years and years. And this year, 2022, we had several industrial trials. So we're working with 5, or actually now it's 6 partners, where we've been to and demonstrated our plant for 2 to 5 weeks. And at the beginning of next year, we will be building the first device at a partner's plant. We're now starting our early access program for 2023. We still have some spots open, and we have a booth over there. So far from my side, thank you very much.